This lesson covers the essential principles and provides an overview of autonomous maintenance pillar practices. Through the content of this lesson, you will be able to identify the fundamental elements, to understand the objectives, steps, and benefits of the pillar, as well as the initial considerations to be taken into account for designing the plan to implement the technical and management methodology. In subsequent lessons of the unit, we will analyze these principles and techniques in more detail. Autonomous maintenance is now considered a new system, used to manage daily work in workshops and industrial plants. This new system consists of 3 sets of practices. Technical practices, organized in steps, that optimize the effectiveness of production processes. For example, performing inspection routines to check the condition of machines. Practices that help create new work habits. For example, practices used to properly record and communicate a detected issue. Management practices that guide employees to achieve the best results in each area of the company. For example, conducting effective and brief meetings to assess the results of a workshift. A practice is an action that is developed by applying certain knowledge, always follows a set of rules or routines for doing things, requires prior training, and brings as a consequence some results. The following are the essential technical features that distinguish the autonomous maintenance program. From a technical standpoint, the purpose of autonomous maintenance is to contribute to the optimization of the production system by building a first line of defense against production problems. This is achieved by fully engaging operators in identifying, eliminating, and preventing deviations from normal conditions that may occur in production processes, which result in losses affecting the overall effectiveness of the production system. Autonomous maintenance is based on the principle of continuous improvement, known as Kaizen or improvement in small steps. This incremental approach allows for setting constant challenges for work teams, and generates satisfaction when goals are achieved in each phase. The Japanese Institute of Plant Maintenance, JIPM, suggests developing autonomous maintenance in 7 steps, each with both technical and human development purposes. These steps start from restoring basic equipment conditions, and gradually progress toward developing autonomous management of the workplace. The autonomous maintenance program is designed to recurrently follow the CAPDO cycle, which consists of check, act, plan and execute. This cycle, a version of the well-known Deming PDCA cycle adapted for TPM, allows operators to acquire technical competence through repetitive practice. Gradually, they develop skills to perform autonomous supervisory tasks. To develop each of the autonomous maintenance steps, a variety of techniques are employed to standardize the actions to be executed. These techniques not only facilitate standardization, but also serve as tools for the progressive training of operators. It is important to have a management system that facilitates the monitoring of the progress of improvements in the production system, as well as the implementation of each step of the methodology, and the development of employee competencies. Within the TPM framework, management systems are characterized by the use of 2 types of practices: visual management through boards and short, effective conversations that take place in front of these boards. Autonomous maintenance is distinguished by its fundamental human aspects. Within the industrial sphere, autonomous maintenance implies that operators are trained and take responsibility for autonomously and responsibly managing operations in their designated areas. It enhances workers' entrepreneurial spirit, empowering them to resolve and prevent a high proportion of problems in production processes, thereby reducing losses. It is grounded in mutual trust, recognizing the value each individual contributes to the manufactured product or supplied service. This trust fosters greater commitment, improves communication, and enhances job satisfaction. It promotes work in small teams, where collaboration is essential. When carried out under the principles of responsible autonomy, employee satisfaction and motivation are increased. It introduces a new perspective on the role of supervision, transitioning from a traditional command and control approach to that of a coach and mentor. Supervisors act as true mentors to their teams, contributing to the technical development and personal growth of the workforce. Autonomous maintenance offers a significant advantage in improving the organization's performance. Its development structure comprises a pillar committee with representatives from various areas of the factory, and work teams composed of operators. These teams facilitate more effective communication and coordination between areas, as well as more efficient delegation, increasing commitment to team goals. Being non-hierarchical, these teams have the flexibility to address incidents agilely, and to propose and implement innovations without bureaucratic hurdles, since everyone involved is part of the teams working towards a common goal. The Pilar's development methodology, through 7 steps, allows for standardizing the work and assigning roles and responsibilities to each team member. These standards are created by the team itself, which increases the commitment of all members of the pillar committee and work teams. Let's take a look at the importance of autonomous maintenance in improving the reliability of machinery and the effectiveness of the production system. The classification of the causes of equipment failures helps to build statistics that can be very useful in diagnosing chronic problems in machinery. About 70% of equipment failures could be identified and solved through autonomous maintenance actions. Figures published by the consulting firm AMS on a survey of manufacturing industries show that at least half of these failures could be prevented if operators have the necessary technical skills and competencies, and there is an effective communication and coordination system with maintenance departments. The remaining 30% of the causes of equipment failures in this study are more complex problems and are usually solved by specialist maintenance personnel. We do not have figures for the continuous process industry, and these may be slightly different, as preventive maintenance strategies and advanced maintenance models are responsible for solving about 75% of equipment failure problems. However, in this class of industries, operational personnel are essential to identify and correct process problems and issues, which also significantly affect overall production efficiency. From the moment that the actions of conservation of the basic conditions of the equipment are carried out, such as keeping them clean, lubricated, and adjusted, the principle of prevention in maintenance is applied. The lack of care and conservation of these basic conditions of the machinery can cause the appearance of anomalies and other latent defects. Although initially, these problems do not interrupt the operation of the equipment, over time, they can generate breakdowns, some of which can become serious. The secret of autonomous maintenance in its first phase is to carry out an exhaustive work of identification and elimination of these anomalies and defects. The objective is to prevent unscheduled shutdowns, product quality defects, accidents, contamination, and other problems resulting from the lack of attention and conservation of basic conditions, which may seem irrelevant at first. An anomaly is a symptom or signal that a machine or system is deviating from an established ideal state. It is crucial to note that anomalies are often overlooked in many companies. These anomalies are indicators that signal the presence of situations or symptoms that, if not addressed, can trigger serious failures, with a significant impact on operational productivity. During the initial phase of autonomous maintenance, especially in the initial steps, the focus is on performing thorough inspections of equipment to detect and correct as many anomalies as possible. This effort constitutes the first line of defense against breakdowns and serious machinery problems. An effective practice in autonomous maintenance involves establishing databases that facilitate the tracking and analysis of the troubleshooting process. It is crucial to avoid mixing information on breakdowns, process failures, and anomalies in these databases. Later in this unit, we will go into more detail on this topic. The activities of cleaning, lubrication, and tightening or adjusting bolts are actions that determine the basic conditions of the equipment. To drastically reduce breakdowns and other issues in machinery, these basic conditions must be addressed systematically and persistently. Autonomous maintenance enables the maintenance of established conditions, improvement of equipment and work methods, and enhances people's awareness to aid in equipment maintenance. Cleaning involves removing any foreign substances or particles adhered to the equipment. These substances can cause abnormal vibrations, pipe blockages, abrasions, burns, faulty operations, and decreased precision, among other problems, leading to stops and breakdowns in sliding parts, hydraulic systems, electrical systems, and instrumentation. Equipment deterioration due to lack of cleaning is a typical example of forced deterioration. Cleaning does not aim to enhance appearance. Its objective is to establish basic equipment conditions and reveal hidden defects to eliminate breakdowns. Lubrication is essential to ensure that parts interacting with each other, or rotating parts, maintain normal operating conditions. Incorrect lubrication can lead to abnormal operating conditions such as vibrations, noises, overheating, abrasions, and accelerated wear of parts. Lubrication is one of the most important requirements for preventing deterioration and maintaining equipment reliability. If components or parts are not properly tightened, vibrations, misalignments, safety risks, leaks, and loss of precision in machinery can occur. These defects can quickly escalate from moderate to critical, and result in effective production time losses, as frequent adjustments are required. Restoring the three basic conditions of the equipment is the most important technical purpose of the initial steps of autonomous maintenance. When steps 1 and 2 of autonomous maintenance are developed, the effects on the results are truly extraordinary. By eliminating more than 70% of anomalies in 1 year, maintenance cost reductions of more than 15%, or improving overall equipment efficiency, OEE, by more than 10% can be achieved in a pilot area. The Autonomous Maintenance Implementation Program has been designed in a step-by-step structure. It's recognized that transforming any system, especially the human one, is best achieved through gradual and systematic changes. For this reason, the Japanese Institute of Plant Maintenance, JIPM, has established a methodology for implementing autonomous maintenance in 7 sequential steps, grouped into 4 phases. Implementing autonomous maintenance in steps facilitates its adoption, especially considering the need to progressively develop the human skills that operators must acquire. Once it's ensured that a person reaches the specific competencies of each step, they can move on to the next one. Moreover, progressing step by step creates a sense of accomplishment in the workers, who see certification of their progress as recognition, thus increasing their motivation to keep learning and growing. From a perspective of autonomous maintenance development management, the step-by-step structure allows standardizing plans and auditing progress, according to the standards suggested by the JIPM, which can be adapted to each company's characteristics. Finally, each step contributes to maximizing the overall effectiveness of the team. The initial steps focus on stabilizing the equipment by identifying and eliminating anomalies and hidden defects. Advanced steps contribute to sustaining the improvements achieved and addressing problems associated with process and product quality. The implementation process of autonomous maintenance begins with the development of a 5S program. Although the 5S are not part of the steps of this pillar, it is necessary to prepare the work areas, both in their physical conditions and in raising awareness among the personnel of the pilot area. The 5S has the benefit of integrating activities to improve the quality of the workstations, develop competencies for detailed observation of the area, and introduce concepts of improvement management, which are essential principles for the successful development of the initial steps of autonomous maintenance. It is not necessary to wait to achieve a level of development of the 5th S to start autonomous maintenance practices. It is possible to develop a first experience in an area that has achieved a level of certification of the 3rd S. The development of the 4th and 5th S can be integrated as part of the activities of the first 2 steps of autonomous maintenance. Possibly, the most delicate work that must be done to guarantee success in the introduction of autonomous maintenance is the preparation for its launch, which we have called Step 0. This step includes a set of vital actions to achieve the involvement of the personnel of the plant or factory. The first conversations held with the operators on the topic, the way in which work teams are trained, the design of the new role of management or supervision, the design of the management systems that will be used, motivation campaigns, etc., are actions that must be carefully prepared to gain the trust of the operational personnel in the project. The development of autonomous maintenance has been structured by JIPM into 7 steps, which are grouped into 4 phases. Each of these steps contributes to improving process productivity and gradually establishes a new management system in the factory. The first phase of the Autonomous Maintenance Development Program consists of steps 1, 2, and 3. It is the starting point for autonomous maintenance, and also for all TPM activities. This phase comprises activities designed to restore the equipment's basic and original conditions, while providing operators with a solid understanding of autonomous workplace management. This is achieved by establishing appropriate methods for cleaning, inspecting, adjusting, and lubricating. As a result of this phase, an efficient system is implemented to ensure the maintenance of basic equipment conditions and optimal operation. In the following, we will analyze how these 3 steps of the pillar work. Step 1. Initial cleaning and inspection. The main objective of the first step, called initial cleaning and inspection, is to thoroughly clean the equipment and detect as many anomalies as possible. This involves taking corrective measures to address the identified anomalies and ensure optimal equipment operation. Step 2. Elimination of contamination sources and hard-to-reach areas. In the second step, contamination sources and areas with difficult access in the equipment are eliminated. This step specifically addresses anomalies related to contamination, as well as factors affecting safety. Measures are also implemented to improve cleaning times and facilitate access to areas that are difficult to inspect, lubricate, clean, and adjust. As a result, a highly effective provisional standard for equipment maintenance is established, which will be continuously improved in the subsequent steps. Step 3. Standardization of cleaning, lubrication, and adjustment. The purpose of the third step, called standardization of cleaning, lubrication, and adjustment, is to educate operators on lubrication practices, identification of points and surfaces requiring lubrication, and establishment of standards for the lubrication and adjustment process. Additionally, improvements are implemented to facilitate inspection and lubrication, and efforts are made to further optimize the times established in the provisional standard. The second phase of the Autonomous Maintenance Development Program covers steps 4 and 5, which aim to prepare operators to achieve a high level of technical competence and gain deep knowledge about their equipment. Through this training, operators will be trained to identify both hidden equipment defects and quality problems arising from machinery parts and systems. The main activities in this phase focus on equipment inspections, quality, safety, as well as environmental aspects, as part of a routine system of work area management. Step 4 is of vital importance and requires considerable time for its development, estimated to be over a year, due to the need to train operators in a wide range of technical competencies. This will enable them to carry out specialized checks on equipment, intervene in deteriorated components, and perform other maintenance tasks within their reach. During this step, continuous review and improvement of autonomous maintenance standards and inspection methods are carried out. Step 5, known as Autonomous Maintenance Standards, aims to redefine inspection routines between production and maintenance departments. These standards integrate cleanliness and lubrication criteria obtained in Step 3, as well as those obtained in Step 4, establishing optimal standards and programs for autonomous maintenance. At this stage, the use of controls and visual signals on equipment is promoted to enhance inspection effectiveness. The third phase of the development program covers Step 6, known as Autonomous Quality Maintenance. The previous steps of autonomous maintenance have been oriented toward the goal of zero breakdowns. At this stage, the focus of operator activities is on ensuring process and product quality, with particular attention to equipment parts and systems that can affect the quality of manufactured products. Finally, Phase 4 of the program comprises Step 7 or Autonomous Work Center Management. In this phase, operators are prepared to analyze and solve more complex problems, conduct effective daily team meetings, manage work center results, review the progress of their improvement projects and work standards. They also participate in weekly meetings with area managers to evaluate results, receive feedback and coaching.